What up, what up? Today, on our adventure of Back to Basics, we're talking about absolute value inequalities. Now, in a previous video, we talked about absolute value of equations, which were Now we're going to talk about absolute valuable inequalities. They are valuable, but we're going to talk about absolute value inequalities, and they're worse. So enough chit-chat, because I can't really do that too well. This is my brainchild. I'm a wordsmith, as you can clearly see from about 30 seconds ago. I created a foolproof system to help you remember how to do these problems, and it's called greater less than. Now, what greater less than is... My puppy's back. If you didn't see my last video, lots of puppy in that video. Her name's Stella. Greater less than says this. If I have the absolute value of blah, blah, blah greater than a number, then what I'm going to do is I'm going to split it up into two parts where I keep the entire equation exactly as is, or I flip everything less than the negative version. Okay, so if I'm given absolute value of stuff is greater than... How do we screw this up? Come on, I just want to make you smaller. There we go. If I have the absolute value of stuff is greater than a number, I split it up into two equations where I keep one exactly the way it was, just no more absolute value. I have the word or, and then I keep the left side the same, flip the sign, and then make it the negative version. Similarly, if I have the absolute value of stuff is less than a number, I'm going to write out the original equation exactly the way it was, just no more absolute value, and then I flip the sign and make it negative. So I never said it would be easy. I just said it would be fun. So let's have some fun, shall we? We have a less than, which means it's going to be an and problem. I'm going to isolate the absolute value. Oh, look at that. It already is. I'm going to rewrite the equation exactly how it was at the very beginning. 3x is less than 9. Since it's an and, I'm going to write out and then I'm going to write out the second equation, inequality, I guess I should say. It's not equation. 3x, flip the sign, make the 9 negative. Okay? I solve each one individually. Divide by 3. Divide by 3. X is less than 3. I solve the right one. Divide by 3. Divide by 3. X is greater than negative 3. And this is the word and. Now, you may remember from the video 2 videos ago with regular old compound inequalities. When I make a compound inequality, let me get a couple numbers here. What do I have? 3 and negative 3. Could I make that work? Negative 3, negative 2, negative 1, 0, 1, 2, 3. Negative 3, negative 2, negative 1, 0, 1, 2, 3. What I do is I graph each one separately. If it's an and, I graph each one separately. Notice that I'm not filling in the circle for 3 because it doesn't count. And I'm going to do greater than negative 3, so I'm going to put the circle here. Terrible line drawing by me. Good thing I'm not a tattoo artist. But since this is an and graph, I care about everything in between. So I am going to put a circle at negative 3, but not fill it in because it's not included in both. And I'm going to put a circle at regular 3 and not fill it in because it's not included in both. But what is included in both is everything in between. Yeah. So pretty much the original problem is saying the absolute value of 3 times what is going to be smaller than 9? Well, 3 times 0 3 times 1, the absolute value of that's smaller than 9. 3 times negative 2 is going to be negative 6, which the absolute value is smaller than negative 9, regular 9. So, yeah. So as long as things go well, the less thans are going to deal with stuff in between most of the time. Most of the time. Not all the time. So I even hesitate saying that phrase, but I said it. Great or less than. Well, this is a great or problem. And so what I do is I isolate the absolute value, already done. I'm going to rewrite the original equation just without the absolute values. There you go. I'm going to write out the other one where I rewrite out the left side. Oh, I wanted a different color. I'm going to rewrite the left side, no absolute value. Flip the sign, make it negative, which means negative, negative 1. So positive 1. And this is great or. And then I solve each one individually. Okay? 2 times x minus 5 is greater than negative 1. Well, let's add 5 to both sides. Let's add 5 to both sides. Cross u out. 2x is greater than 4. Let's divide by 2. Let's divide by 2. And I've got x is greater than 2. Or add 5, cross u out. 2x is less than 6, divide by 2, and x is less than 3. That took me a second there, and I'm not sure why. Now, with the ors, I could just graph both lines on the same line. So I'm going to graph x is greater than 2. Let me number things out. I have 1 and 3, so I'll just put 1, 2, 3, 4, 5, blah, blah, blah. X is greater than 2 means I put the circle at 2. Don't fill it in. Go to the right. X is less than 3 means I put the circle at 3. Don't fill it in, go to the left. Well, wait a minute. With the double arrows and with the ors, I'm supposed to include everything on that line that the line touches. So since one starts here, the other starts there, and they overlap and completely cover each other, what I'm going to end up with is the entire number line. That's right. What this means is I can pick any number and plug it into that entire equation, and it'll be true. Any number. 5, 12, negative affinity. And this makes sense because this is saying the absolute value of blah, 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 blah has to be bigger than negative. Well, the absolute value of anything is positive. So the absolute value of whatever I choose is going to be greater than negative 1. Ah, that's why it makes sense. That's why it makes sense. Don't just do the math, kids. Understand the why. Of course, whenever I do this, she stops doing it. So is the absolute value all by itself? I don't think so. So I'm going to add 1 to both sides. That's going to be my first step, step number 1. The absolute value of 9x is greater than or equal to. Is that going to change anything? No. So I have absolute value, blah, 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 greater than, great or than, or equal to 9. So this is an or, which means I'm going to write out the original equation or the original inequality without the absolute value, or I'm going to write out the original left side, flip the sign, and make it negative. Yeah. You solve each one individually. 9x is greater than or equal to 9. Well, I'm just going to divide everything by 9. I'm just going to divide everything by 9, and that gives me x is greater than 1 or equal to 1. X is greater than or equal to 1. And I'm going to do this guy where I'm going to divide both sides by 9, divide both sides by 9. X is less than or equal to negative 1. I got my or in between. So I'm going to graph each one both on the line. So x is greater than or equal to 1. So let me do negative 3, negative 2, negative 1, 0, 1, 2, 3. If I'm going to graph the red one, I'm going to put a filled-in circle at 1. Go to the right. And if I'm going to graph the green one, I'm going to put in a filled-in circle at negative 1. Go to the left. And there you have it. There you have it. Okay. I think I have one more. I thought correctly. Stuff to do before I even consider splitting things up. I'm going to subtract 1 from both sides. That gives me 2 divided... Oh, great. I gave myself fractions. Wow. Oh, well. Divide by 2. Oh, my gosh, Stella. Divide by 2. Cross you out. This gives me the absolute value. Come on, the absolute... Battery died. The absolute value of 2y minus 1 is less than negative 5.5, and we'll leave it as a decimal. Now, I'm kind of crossing into Algebra 2 territory here. This is pretty difficult for Algebra 1, but I believe in you. I believe in me. I believe in us. I believe in we. I made that up just now. I'm going to split this up into 2 equations. This is a less than. So I have a big and hovering around. I'm going to write out 2y minus 1 is less than negative 5.5 and 2y minus 1 is greater than the negative version of negative 5.5, which is 5.5. I solve each one individually. All right, I add 1. 2y is less than negative 4.5. I divide by 2. And y is less than negative 2.25. Gross. I add 1. Let's keep going. I meant to make it purple. 2y is greater than 6.5. Divide by 2. Y is greater than 3.25. And I know what's going to happen. If let's just I'll tell you what. Let's just do it. I have all right, so I can yeah, watch what I do. This ain't going to be pretty. Negative 3, negative 2, negative 1, 0, 1, 2, 3, and I'm going to add 4 right there. Why? Well, this guy says that since this is an and statement, I'm going to put a dot at negative 2.25, which lives right around there, and I'm going to go to the left, don't fill it in. And I'm going to put a circle For this guy, for purple, right around there, don't fill it in, go there. And I need to find out where these two lines overlap. Oh, what's that? What's that? They don't overlap? They don't overlap? Oh, you know what that means. This is a NAR solution. Why? Because once I get to this point right here, I ask you, the absolute value of what times 2 minus 1 is going to be smaller than negative 5.5. Well, the absolute value of nothing is ever going to be smaller than a negative because the absolute value of something has to be positive. So this is a no solution because there's no such answer that makes sense. There's nothing I can plug in that when I make it positive, it will be less than negative 5.5. That doesn't make sense. That's wacky. Wacky. It's best to understand the why. And now that joke lands a little bit harder because I understand the why and it's no solution because the letter is Y. Sully, you want to say goodbye to everybody? If this is the first time you howl on screen, this would be the best. Say bye. Bye. Woo!